Hi, welcome to NumPy Tutorial Series. In this lesson, we will learn some basics about random number generation in NumPy. Subscribe to Badger the Teacher and never miss new educational videos. There are many different ways to generate random number in Python. We will check out some of them. You can get uniform distribution random numbers by calling np.random.rand or np.random.random.
I see that there are different parameters for these two functions.
Exactly. For rand, you pass array dimensions as integers, but for random, you should pass a tuple with dimensions.
What is a uniform distribution anyway?
Uniform distribution generates numbers within a range from 0 including to 1 excluding, where any value is equally likely to be drawn. In these examples, we have generated two-dimensional array with 3 rows and 2 columns. You can create an array of any size. For example, it can be two-dimensional array with 1 row and 2 columns. Pay attention to the brackets.
There are 2 pairs, so it is two-dimensional array.
Yes. If you expect one-dimensional array, just pass the number of elements as a parameter, like in the second example. Only one bracket pair in this case. The last example is similar to the one discussed on the previous slide, but with 2 rows and 3 columns.
Hope we won't dive into distribution theory in this lesson.
Don't worry, I will just say that there are many statistical distributions available in NumPy Random. Some of them are shown on the slide. Often, uniform distribution is not what you want.
Agree. Let's better see how to generate integers.
For integers, you can use just randint function. You can pass either just a highest border, like in the first example is 4, then integers are from 0 including to 4 excluding, or you can pass both the lowest and the highest border, like in the second example, then numbers from 1 including to 5 excluding are generated. And of course, you have also to pass array size.
Is it mandatory to type size equal when passing the size of array?
If you specify only the highest number, then you must use size parameter name as I do in the first example. Tuple without size text will produce error. If both lowest and highest numbers are provided, you can just pass tuple without parameter name, like in the second example. However, it's not an error to use parameter name as well. In data analysis and data science, it's crucial to be able to reproduce your results. If you get different results each time you run your pipeline, it's impossible to share your findings because results are not stable. If you try to run the first line several times, you will see each time it produces different values.
Can we get reproducible results then?
To fix values produced by random, you have to configure random generator with a seed number. The second line shows how to create random number generator and use it to generate 4 random numbers. However, when you run the second line several times, you will see each run again produces different results.
This is because the seed number is not provided?
Exactly. Let's see how you can do it. 42 is a seed number in first 2 lines, and we see that the first and the second lines produced identical results this time. The third line shows that with different seed number, results are different. Try it yourself and rerun cells several times. You will see values are fixed. That gives us reproducible random numbers.
It can be very important in my projects even as a beginner.
There are several options of handling random imports. You can go with only NumPy import and type np.random each time, or you can import NumPy random and type just function name. It's up to you which approach to choose. Let's discuss 2 more functions that are not for random number generation, however, are tightly connected with random topic in my opinion. Permutation can mix numbers in a random order. Let's say we have an array of 3 integers from 0 to 5. In original array, elements are in the following order: 1, 4, and 3. With permutation, we can get a copy of this array in which elements are in random order, for example 4, 1 and 3.
Why the original array isn't changed?
It's because permutation always creates a copy of the data. Similar to permutation is shuffle function. However, the main difference is that it shuffles elements in place. It doesn't create a copy, so original array is affected this time. That's it for today, so please practice generating random values both with a seed parameter and without it. In the next lesson, you will learn about element indexing in NumPy arrays. Please subscribe to Badger the Teacher and don't miss new lessons. Let me know in comments below if you need some more detailed explanation on topics we have covered. See you in the next lesson. Bye!